Alright, we're live. Gotta stick this camera in its stand. Looks good. Alright, I'm about 5 minutes past when I wanted to start. I got a little distracted, was messing with my computer. I was formatting a document and kind of lost track of time. But anyway, we're here now, we're live, and I'm gonna just go ahead and get started again. So I don't think there's any point in sticking around and doing a whole bunch of stuff to wait for live viewers, because they always tend to get on here by the time I start anyway. You know, it's really weird. When I stop to talk, nobody joins in, but then as soon as I'm reading, that's when everybody joins in. But anyway, we're going to be reading Jules Verne, 5 Weeks in a Balloon. I don't know if what I just said makes sense or not, but it made sense to me, so I guess that's all that really matters. Chapter 7 in this book. Ooh, it's another 3-page book, or chapter, rather. I'm gonna grab myself just a little bit of water. Okay, excuse me, these words here at the beginning say geometrical details, calculation of the capacity of the balloon, the double receptacle, the covering, the car, the mysterious apparatus, the provisions and stores, the final summing up. So it looks like they're getting to the final stages of preparing for their journey. So let's go ahead and start reading, and hopefully some live viewers will join on here by the time I start. So, Chapter 7. Dr. Ferguson had long been engaged upon the details of his expedition. It was easy to comprehend that the balloon, the marvelous vehicle which was to convey him through the air, was the constant object of his solicitude. At the outset, in order not to give the balloon too ponderous dimensions, he had decided to fill it with hydrogen gas, which is 14.5 times lighter than common air. The production of this gas is easy, and it has given the greatest satisfaction hitherto in aerostatic experiments. The doctor, according to very accurate calculations, found that, including the articles indispensable to his journey and his apparatus, he should have to carry a weight of 4,000 pounds. Therefore, he had to find out what would be the ascensional force of a balloon capable of raising such a weight, and consequently, what would be its capacity. A weight of 4,000 pounds is represented by a displacement of the air amounting to 44,847 cubic feet, or, in other words, 44,847 cubic feet of air weigh about 4,000 pounds. By giving the balloon these cubic dimensions and filling it with hydrogen gas instead of common air, the former being 14.5 times lighter and weighing therefore only 276 pounds, a difference of 3,724 pounds in equilibrium is produced. And it is this difference between the weight of the gas contained in the balloon and the weight of the surrounding atmosphere that constitutes the ascensional force of the former. However, were the 44,847 cubic feet of gas of which we speak all introduced into the balloon, it would be entirely filled, but that would not do, because as the balloon continued to mount into the more rarefied layers of the atmosphere, the gas within would dilate and soon burst the covering containing it. Balloons, then, are usually only 2/3 filled. But the doctor, in carrying out a project known only to himself, resolved to fill his balloon only 1/2, and since he had to carry 44,847 cubic feet of gas to give his balloon nearly double capacity, he arranged it in that elongated oval shape which has come to be preferred. The horizontal diameter was 50 feet, and the vertical diameter 75 feet. He thus obtained a spheroid, the capacity of which amounted, in round numbers, to 90,000 cubic feet. Could Dr. Ferguson have used two balloons, his chances of success would have been increased, for should one burst in the air, he could, by throwing out ballast, keep himself up with the other. But the management of two balloons would necessarily be very difficult, in view of the problem how to keep them both at an equal ascensional force. After having pondered the matter carefully, Dr. Ferguson, by an ingenious arrangement, combined the advantages of two balloons without incurring their inconveniences. He constructed two of different sizes, and enclosed the smaller in the larger one. His external balloon, which had the dimensions given above, contained a less one of the same shape, which was only 45 feet in horizontal and 68 feet in vertical diameter. The capacity of this interior balloon was only 67,000 cubic feet. It was afloat in the fluid surrounding it. A valve opened from one balloon into the other, and thus enabled the aeronaut to communicate with both. This arrangement offered the advantage that if gas had to be let off so as to descend, that which was in the outer balloon would go first, and were it completely emptied, the smaller one would still remain intact. The outer envelope might then be cast off as a useless encumbrance, and the second balloon, left free to itself, would not offer the same hold to the currents of air as a half-inflated one must needs present. Moreover, in case of an accident happening to the outside balloon, such as getting torn, for instance, the other would remain intact. The balloons were made of a strong but light lion's silk, coated with gutta percha. This gummy resinous substance is absolutely waterproof and also resists acids and gas perfectly. The silk was doubled at the upper extremity of the oval, where most of the strain would come. Such an envelope as this could retain the inflating fluid for any length of time. It weighed half a pound per 9 square feet. Hence, the surface of the outside balloon being about 11,600 square feet, its envelope weighed 650 pounds. The envelope of the second, or inner balloon, having 9,200 square feet of surface, weighed only about 510 pounds, or say 1,160 pounds for both. The network that supported the car was made of very strong hempen cord, and the two valves were the object of the most minute and careful attention, as the rudder of a ship would be. The car, which was of a circular form and 15 feet in diameter, was made of wickerwork, strengthened with a slight covering of iron, and protected below by a system of elastic springs to deaden the shock of collision. Its weight, along with that of the network, did not exceed 250 pounds. In addition to the above, the doctor caused to be constructed two sheet iron chests, 2 lines in thickness. These were connected by means of pipes furnished with stopcocks. He joined to these a spiral, 2 inches in diameter, which terminated in 2 branch pieces of unequal length, the longer of which, however, was 25 feet in height, and the shorter only 15 feet. These sheet iron chests were embedded in the car in such a way as to take up the least possible amount of space. The spiral, which was not to be adjusted until some future moment, was packed up, sparingly, along with a very strong Bunsen electric battery. This apparatus had been so ingeniously combined that it did not weigh more than 700 pounds, even including 25 gallons of water in another receptacle. The instruments provided for the journey consisted of 2 barometers, 2 thermometers, 2 compasses, a sextant, 2 chronometers, an artificial horizon, and an altizimuth. I've never heard that before. To throw out the weight of distant and inaccessible objects. The Greenwich Observatory had placed itself at the doctor's disposal. The latter, however, did not intend to make experiments in physics. He merely wanted to be able to know in what direction he was passing, and to determine the position of the principal rivers, mountains, and towns. He also provided himself with 3 thoroughly tested iron anchors and a light but strong silk ladder 50 feet in length. He, at the same time, carefully weighed his stores of provision, which consisted of tea, coffee, biscuit, salted meat, and pemmican, a preparation which comprises many nutritive elements in a small space. Besides a sufficient stock of pure brandy, he arranged 2 water tanks, each of which contained 22 gallons. The consumption of these articles would necessarily, little by little, diminish the weight to be sustained, for it must be remembered that the equilibrium of a balloon floating in the atmosphere is extremely sensitive. The loss of an almost insignificant weight suffices to produce a very noticeable displacement. Nor did the doctor forget an awning to shelter the car, nor the coverings and blankets that were to be the bedding of the journey, nor some fowling pieces and rifles, with their requisite supply of powder and ball. Here is the summing up of his various items, and their weight, as he computed it. Ferguson, 135 pounds. Kennedy, 153 pounds. Joe, 120 pounds. Weight of the outside balloon, 650 pounds. Weight of the second balloon, 510 pounds. Car and network, 280 pounds. Anchors, instruments, awnings, and sundry utensils, guns, coverings, etc., 190 pounds. Meat, pemmican, biscuits, tea, coffee, brandy, 386 pounds. Water, 400 pounds. Apparatus, 700 pounds. Weight of the hydrogen, 276 pounds. Ballast, 200 pounds. In total, 4,000 pounds. Such were the items of the 4,000 pounds that Dr. Ferguson proposed to carry up with him. He took only 200 pounds of ballast for unforeseen emergencies, as he remarked, since otherwise he did not expect to use any, thanks to the peculiarity of his apparatus. That is the end of chapter 7. I did it again. Started looking around trying to find the bookmark, but it's right here in the book. All right. Well, so yeah, that's the end of chapter 7. And this thing is showing me I've got 1 viewer live, but I did not when I finished that chapter. So you just got on here, it looks like, and they just left. So it looks like I didn't have any live viewers. At least none that stuck around to the end. That's kind of unusual. I usually have 1 or 2. But anyway, thanks for sticking around to the end. And if you enjoyed this video and would like to see more, consider subscribing. I'm trying to reach 1,000 subscribers by the end of this year. And if you enjoyed this video, consider leaving a like. That makes these videos more visible to other people. And also, if you think you know someone who might enjoy this video as much as maybe you did, consider sharing. And remember that I will be putting this video in a playlist along with all the other reading videos that I've done. So you can go back and you can look at Treasure Island and you can listen to the other 6 chapters that I've done so far in 5 Weeks in a Balloon. And with that, I will be closing off this live stream. So thanks again, and y'all have a good night. And I'm gonna go over there back to my computer and mess with some, what you call it? I don't know, I just forgot the word, but anyway, I'm gonna mess with that document over there that I've been working on, so y'all have a good night. God bless.